Hello everyone, good evening. Dear authors and invited guests, welcome to Technical Session 10C. Myself, Vidhi Rahamdale, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 11th International Congress on Information and Communication Technology, that is ICICT 2026, London, UK. The 11th edition of the conference is being organized in a hybrid mode. The physical event was held day before yesterday in London, UK, and the virtual event is being held through Zoom from 25th to 27th February 2026. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentations and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce all to the chair of this session. We welcome Dr. Neha Tiwari as the session chair. Dr. Neha Tiwari is working as an associate professor in the Department of Computer Science and IT at IIS deemed to be an university, Jaipur. She is a research supervisor with an experience of more than 16 years and also supervised the students in a variety of projects. Her research domains include networking, machine learning, blockchain, database, software engineering, and cloud computing. Welcome to the session, ma'am. Would you like to address the participants?
Thank you so much, Vidhi, for the introduction. All the very best to the participants. I
We will
hope I
now
was
move on to the
audible
first.
enough.
Yes, ma'am.
Thank
We
you.
will now move on to the presentations. We invite Ianus Monstros to present his paper titled An Augmented Fractional IMC Design for an AVR System.
Good evening. Am I audible?
Yes, we can see your presentation.
Okay. Good evening, ladies and gentlemen. I'm Ioannis Moskos for the Department of Electrical and Computer Engineering from the University of West Macedonia, and I will present you our work titled An Augmented Fractional IMC Design for an AVR System. The presentation is split into 6 parts: the introduction, contributions, some preliminary, proposed methodology, simulation, and finally conclusions. So let's start with the introduction. Power system and distributors must maintain always the voltage deviations within predetermined limits to prevent equipment damage and maintain energy quality. The terminal voltage must always maintain within operating limits, and this can be achieved through the AVR systems. The most common controller used in AVR systems is the PID controller due to its simple design and is usually tuned through mechanistic algorithms. However, with a renewable integration, we have requirements of higher accuracy and robustness. This prompts researchers to study fractional order controllers, which provide improved dynamic performance but are more complex. In our study, we propose an alternative strategy, which is the internal model control, which is a model-based framework. It provides improved robustness and has no dependence on mechanistic algorithms. In summary, our contributions can be a new controller structure which merges a variation of the PID controller with a fractional order filter, the IMC framework without model order reduction, and the model-based design which is not dependent on the metacristic algorithms. Also, a new augmented fractional reference model with additional degrees of freedom to shape the frequency time response easier and enhance the robustness to parameter variations and noise rejections. And finally, we introduce some rational approximations for the proposed design based on continuing fractional expansion. The fundamental principle of the IMC is that it's a model-based design which includes the actual plant and the process model GMS. The difference between the actual output and the model output is used to attenuate disturbances and address model uncertainties. The IMC is mathematically equivalent to the classic feedback controller through the equation shown in equation 1. The IMC design procedure can be split into two parts if we consider the ideal case, meaning that the process model is equal to the plant model. Firstly, we factor the process model into its minimum phase component and its non-minimum phase component. And in the second part, we define the IMC controller as shown in equation 2, where Fs is a low-pass filter with steady state gain 1. Regarding the fractional calculus, its generalization is a generalization of integration and differentiation to non-integer orders. However, fractional order operators are difficult to implement in practical applications. For this reason, we suggest the continued fractional expansion to approximate the fractional operators. For example, if we have s to the power of gamma, it can be approximated as a fourth order transfer function as shown in equation 3, where the coefficients of the numerator and denominator are dependent on their fractional order. An FVR system is designed to control the excitation system of a synchronous generator, ensuring steady terminal voltage. Based on the block diagram, we can conclude that it consists of 5 blocks: the controller, amplifier, exciter, generator, and sensor. And if we find the open loop transfer function, we can conclude that it's a fourth order transfer function without the controller. Our proposed methodology is a hybrid design which merges a PID controller, a variation of the PID controller, with a fractional order filter within the IMC framework. With this, we can satisfy specific fractional characteristics for both open and closed loop responses, which conventional integer order filters struggle to achieve, and fractional order filters reference model in equation 4, where it contains two components. The first component is a fractional, which has the isodynamic property, meaning that it has constant phase, and this characteristic ensures almost constant overshoot in the system step response across a range of gain variations. And the integer part, which provides high frequency attenuation by adding extra phase lag at higher frequencies. So by improving measurement noise suppression and ensuring robustness to unmodeled dynamics in IMC design. Regarding the controller derivation, we assume that the process model is equal to the plant model. It is equal to a fourth order plant, as is a VR system. And by applying the IMC procedure, we can find that the final controller has two components, a fraction and an integer part as shown in equation 5, where ls introduces the fractional dynamics. Regarding the parameter tuning, we have considered a constraint optimization problem in the frequency domain, and as an objective function, we have set the crossover frequency, while the other specifications have been introduced as constraints and inequalities. More specifically, the frequency domain design specifications where the crossover frequency to be equal to 1 rad per second, phase matching equal to 60 degrees, noise attenuation by minus 50 dB for omega greater or equal to 500 rad per second, disturbance rejection to be less or equal to 50 dB for omega to be less or equal to 10 to the power of minus 3 rad per second, and robustness to gain variations. The optimal values that we found are capital T to be equal to 0.005 seconds, lowercase tau to be equal to 0.9996 seconds, and the fractional order to be equal to 0.33. Also, we have compared the proposed model with a standard model shown at the bottom of the screen. First, we compare the frequency domain properties of the two models. We're seeing on the right the body plot of the two models. And for the standard model, we see that it has a constant phase, a constant slope of -8 multiplied by 1.3 dB per decade, which provides smooth attenuation and improved robustness. However, the slope cannot be changed independently because it is dependent on the fractional order of the model. Regarding the proposed model, we can observe that at lower frequencies and around the crossover frequency, the performance is equal. However, at high frequencies, the combined effect of the fractional and integer term yields a roll-off of -20 multiplied by 2.33 dB per decade. Before we move to the time domain, first, we have to approximate the controller. Fractional controllers require rational approximations for practical implementation, which would be simple and straightforward parameter calculation. In our study, we have considered the CFC approximation, as shown on the right, the second, third, and fourth order CFC. We can conclude that the fourth order CFC approximation exhibits reasonable accuracy, complexity, and isodynamic characteristics. And by using this approximation, you can move to the time domain performance. Firstly, we have assessed the isodynamic performance of the proposed model by varying the gain by 50% and 75% from its nominal values, while keeping the controller parameters fixed. By the figure on the right, we can observe that the overshoot remains nearly unchanged and only the response speed is affected. Next, we evaluate the performance of the controller to time constant variations. The results are shown on the right, where we can conclude that the controller is insensitive to variations in the time constants of the amplifier and sensor, and a 5% decrease to the time constant of the generator or exciter increases the overshoot by a small percentage. And finally, you have ejected noise in the sensor channel, and the results are shown on the right. We can observe that both models exhibit comparable transient behavior and effectively attenuate noise. However, the proposed model achieves superior noise suppression, giving a smoother and less agitated response, as shown on the zoom on the figure. Concluding, we have proposed an analytical model-based design providing a systematic alternative to metaheuristic strategies, regular use TPID controllers. The proposed structure is unaffected by gain and time constant variations, while simultaneously suppressing high-frequency noise introduced into the system. The CFC approximations of fractional operators ensures practical feasibility and easy implementation, and as future work, it will be interesting to apply the proposed model to fractional order systems and multivariable systems, derive analytical formulas to make the design simple, and finally, increase the order of the integer filters to introduce more degrees of freedom for shaping the frequency and dynamic performance of the system. Thank you for your attention.
So I have one question for you.
Yes.
Yeah. So this is just an analytical work which you've done so far based on some mathematical derivations, right? The implementation part, the real life implementation part is still left, isn't it?
Yes, we haven't implemented the controller yet.
Yeah. And implementation has its own challenges once we do it. Agree?
Yes, of course, yes.
Okay. So I'll ask you just one important question. Everyone is going for hybrid algorithms or hybrid models these days, combining the positive properties, the traits of the, I would say, extremes of models or the to overcome the flaws of the existing models, I would say. So, do you think proposing a hybrid model has some I would say, drawback associated with it. We are only talking about the positivities of hybrid models. We never speak about their challenges or limitations or any drawbacks. So, do you really think that hybrid model only gives you positive results always in all the cases?
Regarding the implementation, I think that there will be always challenges, and doing a hybrid model is always more challenging, more difficult. For example, if we take the integer model, mm, give me 1 second.
Sure.
If we take the simple the integer model, 1 divided by 1 plus stuff s, the derivation of the formulas is quite easy and easy to implement in the real life. Regarding the fractional term, it's quite difficult to implement it. You require to make a rational approximation, which is quite difficult to achieve. Not because of the model is quite hard to make it, it's of the complexity. You make the model realizable, however, you add more computational complexity and more components. Of course, more components means that there's always a danger in failing one of the components.
All right. Okay. Thank you so much. All the very best to you.
Thank you very much.
Can we move to the next one, please?
Yes, ma'am. We now invite Victor Villaforte Haro to present his paper titled An Immersive Virtual Reality Laboratory for Practical Training in Mobile Telecommunication Engineering.
Yeah, I'm ready. I will start. Just give me a second. Okay. Let's begin with my exposition. Good morning, everyone. My name is Víctor Villafuertearo. I am telecommunications student at the Escuela Superior Politécnica de Chimborazo in Ecuador, with a strong interest in 3D modeling, virtualization, and programming, and even 3D animation. In fact, these interests are the basics of the project I'm going to present today, titled An Immersive Virtual Reality Laboratory for Practical Training in Mobile Telecommunications Engineering. Well, this picture shows me personally in real situation during field training. Working on communication towers involves height, electrical risks, and involves safety equipment. In many universities, students have limited access to real towers and base stations due to costs and safety restrictions. This creates a gap between theory and real practice. This problem motivated the development of an immersive virtual reality laboratory as a safe and accessible training environment. Well, introduction. As introduction, I have virtual reality allows users to interact with simulated environments in a realistic way. In technical education, VR can be used to create complex and dangerous scenarios safely. In this work, we propose an immersive virtual reality laboratory focused on mobile telecommunications engineering. The virtual environments allow the students to practice tasks such as antenna installations, cable connections, and base stations configuration without physical risks. Related, related work. Several previous studies have applied virtual reality in engineering and technical education. These works report improvements in practical understanding and student motivation when immersive environments are used. However, most exciting VR training systems are focused on industrial or mechanical scenarios. Um, there is limited research specifically addressing mobile telecommunications training, which motivates the development of the proposed virtual laboratory. The main objective of this work is to develop an immersive reality laboratory for practical training in mobile telecommunications engineering. Specifically, the system simulates base station component such as antennas, cables, and control equipment. It also provides an interactive and safe environments for students to practice technical procedures. Finally, the platform is evaluated through usability tests with students to analyze their learning experience. The methodology. The methodology of these works is based on several stages. First, technical and educational requirements were analyzed to define the function of the virtual laboratory. Then 3D models of base station elements, antenna elements were created and integrated into a virtual environment using Unreal Engine. The development and programmation is also made in Unreal Engine with blueprints. The system was adapted to work with virtual reality devices for immersive interaction. Finally, usability tests were conducted with telecommunication students to evaluate the experience and functionality of the system. Yeah, system development. Before developing the final virtual laboratory, preliminary tests were performed using Unreal Engine and virtual reality devices. A basic virtual environment was created to validate interaction, movement, and visualization in immersive mode. Give me a second. As we can see in this little clip, I'm just testing if the motion controllers are working in correct way before start programming, before start my development of my final laboratory. In this case, yes, we can see that the controllers are working correctly. This test allow verifying correct perspective, user construct, and system performance before implementing the complete laboratory scenario. Yeah, virtual environment design. This slide shows the visual design of the virtual environment. The system recreates real space on the Spoch campus. We can see in these three different spaces on Spoch campus, including the structure, a mobile base station. The students can explore different area of the campus and realistically approach telecommunications equipment, as well as explore facilities and buildings and even recreational areas such sports area and parks. The antenna towers were modeled to represent the actual technical infrastructure used in mobile networks, which can then be used and interacted with within the virtual campus. User interaction and technical tasks. Yeah, at this stage, the user directly can interact with the environment. A virtual tablet in the environment is used as an interface to access to technical control and know-how. Through this interface, the user can select different type of antenna, different type of towers from an interactive menu. The selected antenna can be placed at specific location in the environment to simulate basic installation and configuration procedures used in mobile telecommunications system. System validation. For system validation, usability tests were conducted with telecommunication students. Let me play this. First, the participants recite basic instructions on how to use the real the virtual reality devices, as shown in this short video. The general guidance is provided, ranging from how to put on the VR headsets to how to start running. Oops, sorry. How to start running using the virtual environment. It's a little explanation. Then they interacted with the virtual environment and performed technical tasks. Finally, the experience and feedback were collected in order to evaluate the system functionality and educational usefulness. Results. The results show that the proposed virtual laboratory was successfully implemented. Students were able to navigate to environment and interact with the simulated elements. They complete basic tasks such as antenna placement, system interaction without major difficulties. In general, the feedback we obtained was positive in terms of usability and learning experience. In conclusion, virtual reality proves to be viable tool for practical training in mobile telecommunications engineering. The development system allows students to simulate technical procedures in a safe and controlled environments. The virtual laboratory supports learning through immersive interaction and hands-on experience. This approach can be extended to other technical training scenario in engineering education. Future work, the system can be expanded by integrating additional telecommunication equipment and more complex scenarios, more complex tasks. Mandatory personal protective equipment, the famous PPE, verification could be implemented, requiring the user to correctly wear safely equipment before climbing any tower. A guided training mode may also be added to provide this step-by-step technical instruction. Finally, the platform could be extended to support collaborative or multi-user training environments. But here we have some limitation. As with any prototype system, this work has some limitation. First, the validation stage was conducted with limited number of students for the first semester grades or older students. Second, the simulated technical produced are basic and intended mainly for introductory training. In addition, system performance depends on the available hardware resource. Finally, advanced safe protocol and personal protective equipment verification are planned for future versions. Thanks for your attention. I will be happy to answer your question.
Victor, is it a part of your research work or you're doing some project?
I'm sorry,
Is it a
excuse
part
me.
of your PhD, your research work, or are you doing a project? Are you associated with some project?
It's my project. It's my university
It's
project.
your project. Are you a student?
Yeah, excuse me.
Are you a student, like some postgraduate student, or which course are you doing right now?
Okay. Don't understand very well, but I understand that it's my project. I'm implementing in this moment. It's not the final version.
No, no, I got it. You're doing it as a part of your project, but is that project a part of some curriculum? Are you a
No,
student?
no, no, no. It's just this project for this conference.
Okay. So, do you have some other team members as well?
Excuse me.
Do you have some other team members in your project work, or you're the
No,
only one
it's
doing it?
I'm the only man working on
Okay.
this.
All right. So I would quickly say two, three things to you. Firstly,
Okay,
you're doing a good job, but I
thank
can
you.
see some gaps in your motivation. and the objectives which you set. So I would suggest you to go through the review, literature review once again, and figure out if there are already some systems which are working, some real life systems which are working on the same grounds for which you have done this project. Yeah.
Because yeah, I want to show more, but I can because the computer that I am using for this project it's not mine. It's property of the my university, and I have no access to present.
No, no, I understand that. You've done a simulation work, right? But I'm
Yeah,
saying that there are some systems in real life which are including the functionalities which you suggested or which you've proposed, right? So there are
yeah.
systems which are already implementing that, and
Ah,
many
yes.
people are using it in real life. So I would say the idea is good, but take up some problems which are not yet addressed by anybody. So for that, you will have to review the literature work once again, and then set your
Okay.
objectives accordingly. All right.
Yeah.
Wish you all the luck. Thank you.
Thank you too.
Please call up the next one.
Yes, ma'am. We now invite Siddesh Patil to present his paper titled Artificial Intelligence in Environment, Social and Governance Practices.
Good evening, everyone, and thank you for the opportunity to present our work. I'm Siddesh Patil. I'm a student of Business Administration at Symbiosis University, and our paper is titled Artificial Intelligence in Environment, Social and Governance Practices. Basically, this is a bibliometric review paper. So nowadays, as we see, AI is increasingly becoming part of the core infrastructure that supports modern decision-making systems. And at the same time, environment, social, and governance, or what you call as ESG analysis, have become critical for evaluating sustainability, environmental risks, and corporate responsibility. What we are now witnessing is the convergence of these two domains, where AI is no longer just a supporting analytical tool, but it is also becoming embedded within the ESG ecosystem itself. So we wanted to explore how is AI actually shaping the ESG research and its technological evolution. So this study aims to answer that question by analyzing the global research landscape of AI in ESG over the past decade or so using a bibliometric analysis. To understand the motivation behind the study, we have to appreciate how ESG decision making has changed in recent years. So traditionally, ESG evaluation relied heavily on manual analysis of sustainability reports, financial disclosures, or corporate governance data. However, today the ESG data is no longer in smaller chunks, and the structure of this data is no longer simpler. So organizations now generate massive volumes of sustainability related data, including environmental metrics, operational data, or regulatory disclosures, reports, etc. And processing this data manually is inefficient, and it also limits the accuracy and also the scalability of ESG analysis. And this is where the application of AI in this field becomes critical. AI enables automated processing of large complex data sets and allows the organizations to extract meaningful patterns that would be difficult to identify manually. And as a result, AI is increasingly becoming integrated into ESG workflows, supporting functions like sustainability assessment or risk evaluations, and they are also helping in making investment decisions. Now, this technological shift has led to rapid growth in research, which is at intersection of these two domains, that is AI and ESG. So the motivation for this study is to see how this research is evolving and what does it tell us about the role of AI in ESG systems. Now, although the research on AI and ESG has grown rapidly, most existing studies focus on solving specific problems. For example, some studies develop machine learning models to predict, let's say, ESG scores of some entities, while others apply AI to analyze sustainability reports and so on. Now, these studies are definitely valuable, but they tend to focus on individual applications that are in isolation. What we find still missing is a broader system level understanding, specifically a high level view of how the overall research landscape is structured and how different research domains are connected. Which countries and institutions are driving this development, or how the field has evolved over time. So this research tries to address that gap. So to address this gap, this study is guided by these research questions. The first question examines how AI ESG research has evolved over time, which helps us understand whether the field is emerging, expanding, or maturing. The second and third questions focus on identifying the key contributors, including countries, authors, and journals. This helps us reveal where technological leadership in this field is concentrated. The fourth question examines the main research themes, which provide insights into how AI is actually being applied within ESG. Finally, the fifth question addresses the structural architecture of the field, which helps us understand how different research domains and technological components are connected to each other. So to answer these questions, we did a bibliometric analysis of 399 articles from the Scopus database, and they're covered from the period between 2014 and 2025. And the analysis was performed using tools like BiblioShiny and VOSViewer. So while we are looking at the publication trend, what we see is that between 2014 and 19, the research activity in this area was limited. The field remained almost stagnant for nearly 6 years, and this suggests that during this period, AI in ESG were largely developing as separate domains with very little integration. However, starting around 2020, there is a clear structural shift. The number of publications begins to rise rapidly and then increases dramatically between 2022 and 2024. Now, this kind of exponential growth is usually seen when research areas move from being experimental to becoming strategically important. In this case, it suggests that AI is no longer being explored as a theoretical tool for sustainability, but it is increasingly being adopted as a practical and operational component of ESG analysis and also in decision making. Now, this marks the transition of AI in ESG from as an emerging topic to establish a research domain. So the interpretation is basically when we combine the publication trend with the keyword and journal analysis, we can clearly see that AI ESG research has evolved through distinct developmental phases. Like the first phase before 2019 can be understood as an exploratory phase. During this phase, researchers were beginning to experiment with the idea of applying AI to sustainability, but there was no clear research direction or large-scale adoption. The second phase begins around 2020, where this phase is characterized by expansion into applied use cases. We begin to see research which is focusing on ESG performance measurement, sustainability analytics, and financial applications. And now this suggests that the AI was starting to move from conceptual exploration into practical implementation. The most important phase begins after 2022. Here, the growth is not only quantitative, but it is also structural. So research becomes more interdisciplinary, which spans across sustainability journals, engineering journals, and financial journals at the same time, which indicates that AI is no longer being treated as an external tool, which is applied to ESG practices, but it is also being embedded within the ESG ecosystem itself. In other words, AI is transitioning from being used for ESG analysis to becoming part of the ESG governance infrastructure. And this is a very important structural shift. Now, this slide shows where the technological development of AI and ESG systems is being driven and who is shaping the field. The first observation is the dominance of China, which significantly higher publication output than other countries. This reflects their large-scale investments in AI and its use of AI in governance and sustainability-related systems. We also see a strong contribution from the United States, India, the United Kingdom, and other European countries, which are major global AI innovation hubs. Another important point is the presence of international collaborations, which suggests that AI ESG domain is evolving as a global technological ecosystem rather than isolated national efforts. And finally, if you look at the H index of the authors, we see moderate but not extremely high values. And this indicates that the field is still emerging and it is distributed across multiple contributors. From a technology perspective, what this suggests is that AI in ESG is still in an active developmental phase, where new computational approaches and system architectures are continuing to evolve. Now this slide reveals how AI ESG research is being integrated across different technological and application domains. The journal Sustainability becomes the dominant publication source after 2021. And this indicates that AI is increasingly being used to solve real sustainability and governance problems rather than remaining confined to theoretical AI research. At the same time, we see strong contributions from technical platforms like IEEE and ACM conference proceedings. This is significant because it shows that AI in ESG is not just a sustainability topic, it is also being treated as a computational and engineering problem. In other words, researchers are not only studying AI and ESG in isolation, they are building technological systems to analyze and as well as manage ESG using AI. Now let us come to the keyword analysis. The keyword structure provides important insight into how AI is architecturally integrated into ESG systems. So if we look closely, these keywords align with the functional layers of a typical AI system. Like at the foundation, we see terms like big data, machine learning, and algorithms. These represent the data processing and model layer. So where AI systems ingest large volumes of ESG data and build predictive or analytical models. Above this, we see keywords such as decision making or risk assessment and prediction. And now this corresponds to the intelligence layer where AI models generate insights that support the governance and investment decisions. At the application level, keywords like sustainability, governance, climate change, and the investment, these represent the domain layer where these AI outputs are applied to real ESG problems. And finally, the presence of terms like corporate governance and economic performance indicate the strategic layer, where AI-driven insights influence the organizational and financial decision making. So overall, this keyword mapping shows that AI in ESG is evolving as a complete computational pipeline, which starts from data ingestion to model development to decision support and to finally the strategic implementation of these outputs. Now, this confirms that AI is becoming an operational backbone for ESG-related intelligent systems. So when we synthesize all these findings, a clear reference architecture, sort of an architecture for AI-enabled ESG systems begins to emerge. At the foundation, we can say that there is a data layer where AI system ingest large volumes of data, ESG-related data, such as sustainability reports, financial disclosures, environmental metrics, and operational data. This data is then processed in the analytics and model layer, where machine learning algorithms transform raw ESG data into structured indicators or predictions or risk assessments. So above this, there is the governance and decision layer where these AI-generated insights are used to support functions such as compliance monitoring or ESG-related scoring or risk evaluations. And then at the top, there is the strategic application layer where these outputs directly influence sustainability planning or investment-related decisions or the governance strategies of corporates. Now, what this layered structure shows is that AI is not operating as an isolated tool, but as an integrated kind of a computational backbone that kind of connects the ESG data and analytics to the corporate level decision making. That is the business side and the technology side of ESG. Now, this architecture is being driven by three key factors. First is the rapid growth of ESG related data. Second is increasing regulatory requirements. And third is advances in the capabilities of AI itself. And together, these forces are enabling the development of fully AI-driven ESG intelligent systems. So up to this point, most research in this area has focused on developing individual AI applications for ESG, such as prediction models or sustainability analytics. What this study has attempted to do is that it provides a structural and a system level, very high level understanding of the entire research landscape by analyzing publications over more than a decade. So the analysis indicates that AI is not simply being applied to ESG as an external tool. Instead, it is becoming integrated into the core computational architecture that supports ESG analysis, governance, and decision making. And in that sense, this study helps us understand AI and ESG is not just a research topic, but it is coming up as an emerging technological ecosystem. This this perspective is particularly important for designing future AI-driven sustainability and governance systems. Now, to conclude, this study shows that AI in ESG research has undergone a fundamental uh, transformation over the past decade. What began as a small exploratory research has rapidly evolved into a major interdisciplinary field, and AI is increasingly becoming part of the computational infrastructure that enables ESG systems themselves. Now, this shift has important implications as ESG data continues to grow in volume and complexity as well. AI will become essential for processing that data and supporting governance and the decision making. Looking ahead, uh, this sort of creates several important research opportunities. One key direction is the development of some standardized AI-based ESG evaluation systems that can operate reliably across different organizations, different types of organizations, and also different types of geographies. Another important direction is improving transparency and explainability in these AI-driven ESG models so that their decisions can be trusted, especially when we are living in the area of greenwashing, where corporates are already being alleged of uh, misrepresenting their ESG-related data. We need to make sure that AI-related analytics is also trusted. And we are also likely to see the emergence of real-time ESG monitoring systems, which are then powered by AI. So finally, there is a growing need to address the governance and regulatory challenges that arise when critical sustainability decisions are increasingly made by AI systems. So overall, as a conclusion, this study provides a structural foundation for understanding how AI is reshaping ESG research and its technological future. Thank you very much.
Okay, Siddesh, if I'm not mistaken, are you a BBA student?
No, ma'am, I am an MBA
MBA
student, ma'am.
student? All
Yes,
right.
ma'am.
Okay. So it must be a part of your research work, the curriculum, right?
Yes, ma'am. This is part of my
Okay.
research.
All right. So, how did you handle the pre-processing part of your work?
So for this bibliometry study, right, ma'am?
Yeah.
So basically, we have Scopus access through our institute, and we did some keyword search from on the Scopus database. That was AI and ESG, and from those we referred to the this time period from 2014 to 2025,
No,
and we
actually,
limited.
Siddesh, the question is that you
Yes,
you took the help of a few tools, AI-based
yes, ma'am.
tools, right, to
Uh,
filter the data. You
yeah,
supply the data to it. So, but
yes, ma'am.
we directly don't supply the exact data which is available over the Kaggle to the tool, right? There has to be some pre-processing done to handle the biasness of data, or many other aspects are also there. In fact, pre-processing part has also some functionalities attached to it. It's quite a big thing, until unless you supply the correct data to it, uh, it can mess up the entire result that you must be knowing. So I just want to know how you handle the data initially.
Yes, ma'am. So basically, we directly took the data from the Scopus database, that's a big text file and CSV files, and we fed those files. So basically, there was a data sheet of those 399 articles, and that data itself was fed to the BiblioShiny and WatchViewer analytical tools. So I'm sorry, ma'am, but the pre-processing part was not done in
I
our
know,
research.
I know that. So that is
Yes,
why I'm
ma'am.
suggesting you that
Okay, ma'am.
the overall idea is good, the
Yes, ma'am.
concept is fine,
Yes,
but
ma'am.
when we, even if we are writing a paper or we take up a research work, there has to be a proper procedure of going about it, right?
Yes,
So
ma'am.
firstly we must talk about the problems pinpointedly. If I can see your title, the paper title, itself is very, very broad. You're talking about environmental, social, and then government
Governance.
data. Yeah.
Yeah.
So
Yeah. Yeah.
that's huge, I would say, and
Mm-hmm.
contrasting directions you are taking up and you talked about. And then
Yes.
the objectives which you set didn't consider much of the factors your title is speaking about. And
Mm-hmm.
whatever inferences you drew out of the concept which you applied, and the output that you got from the tool doesn't
Mm-hmm.
correlate with your initial work. So there has
Yes.
to be specific, I would suggest take the help of your fellow writers, discuss it with them so that you can improve upon the very, very important and core part and concepts of paper presentation, and maybe taking up some future work in this direction.
Sure, ma'am. Sure, ma'am. We'll definitely go ahead in that direction. Thank you, ma'am.
Good
Thank you
luck
for your
to you.
feedback.
Yeah.
Yes. Thank you.
Next one, please.
Yes, ma'am. We now invite Connor Weldon to present his paper on auditing emotional AI data sets with the data diversity wheel.
So, hello, my name is Connor. It's great to be here, and thank you for having me. I speak very fast, so I'll do my best to slow down. Um, but I'm a student, a PhD student in MTU, Munster Technological University, which is based down in Cork. So, the talk today that I want to go through is a practical problem in emotional AI, and it's dataset biasness that gets amplified because affect is expressed differently across various language varieties, cultural norms, discourse style, and where people choose to share it, neurodiversity. I'm presenting today the data diversity wheel, in which I'll show you later on in my slides. This is a compact audit tool that turns be fair and ethical into concrete coverage checks, targets, and reporting that teams can actually ship with a live dataset. I'll cover the wheel and why intersections matter, the audit workflow, and a small toy walkthrough showing how you would detect shortfalls and report them transparently. The starting point is simple. Emotional AI systems are only as good as the dataset they learn from. But affect isn't expressed uniformly. The same intent can be read as neutral, rude, or sad, depending on dialect, indirectness, and emoji conventions, as well as a broader communications norm. So if the dataset mostly reflects one default group and one default style, you're effectively training the model to misread every single other style there is. And the dangerous part is global metrics can still look fine while specific subgroups are constantly being misinterpreted. That's why we need an audit that goes beyond demographics and explicitly checks cultural expression and does it at the intersections. Our contribution here is intentionally practical. First, we formalize the wheel as 3 rings: demographic, cultural, and neurodiversity. And we treat these intersections as the basis of units of coverage, not single axes. Second, we provide a step-by-step audit pipeline. It starts before you touch the data, governance and purpose limitation, and ends with a release bundle teams can ship. Excuse me, sorry. Third, we include templates, a checklist plus tables for coverage targets and peer group metrics with uncertainty. Finally, we include a toy walkthrough showing how you can detect shortfalls, pause or label release appropriately, remediate, and report transparently. This paper also then aims to answer the following research questions. Do intersectional cuts reveal gaps? Demographic-only audits miss? And can target remediation reduce priority gaps without needing a more complex model? So here's the core idea. The wheel is deliberately simple so teams and users can actually use it. The inner ring is the demographic. This is the who. And the middle ring is the cultural. The how effect is encoded. Dialect and language variety, discourse norms like indirectness, honorifics, and emoji conventions. The outer ring then is neurodiversity, but explicitly opt-in because this itself is a sensitive area. And the key points in this is the most important gaps often show up at the intersections. If you only report by age or by gender, for example, you can miss compounded blind spots, like a minority language subgroup that's only underrepresented in a specific communication style. So the wheel forces you to plan, collect, QA, and report at intersection cells, not just a single axis. Now let me unpack what the ring means in practice and the big catch-out, which is pre-processing. On this slide, I'll clarify what the rings mean in practice. The demographic coverage is the baseline. Necessary, but not sufficient on its own. Cultural then. Cultural coverage is the piece many audits miss. Dialect, indirectness, honorifics, emoji, and punctuation conventions. These often carry the effect signal. Neurodiversity then is handled as opt-in. We avoid inference and we document missingness and uncertainty. The point isn't to diagnose, it's to avoid designing systems that systematically misread certain communication patterns. And the big gotcha is pre-processing. Teams often normalize spelling, strip emojis, or standardize punctuation, and that can erase the emotion signal for some groups. So we recommend peer stress tests, run evaluations with and without specific normalization steps, and publish the peer group deltas. Once you accept that, the question becomes, how do we make coverage measurable? That's where the intersections come in. This is the main selling point, in my opinion. An intersection is just a cell formed by combining categories. For example, age group times language variety times communication style. Coverage gaps and QA issues tend to cluster in these cells, not just one axis alone. So you pick a small set of axes that matter for your deployment using 4 criteria: impact, plausibility, consent/ethical observability, and feasibility. Then you use the intersection cells for 3 things: quotas, targets for collection, annotation QA like agreement by cell, and then finally reporting, per cell metrics with uncertainty. And the reason this matters operationally is simple. Triage and tutoring interventions fail when thresholds are tuned only on majority norms. This slide is the method in one view, 6 stages end to end. Stage 0, governance. Define intended use and non-use, assigned ownership, and opening a living risk register. This is all done prior to even seeing any of the data or even creating your data. Stage 1 then is inventory. This lists the sources and modulities, map available attributes into the wheel rings, and explicitly document missingness. Stage 2 then would be coverage design. Define the intersections groups G, set minimum per cell targets, tau G, and declare priority thresholds epsilon for the deployment. Stage 3 then is the annotation and QA aspect. Use cell awareness guidelines, diverse annotators, and report agreement by cell. Stage 4 would be measurement and reporting, which would publish coverage tables, peer group metrics with confidence intervals, and gap analysis against epsilon. Stage 5 then, finally, is the documentation and release. This is to ship the bundle, dataset, the wheel report, the risk register, and change log. And the defensibility point is These are checkable gates. If a gate fails, you pause, remediate, and you document it, rather than hiding issues inside global averages. Slide 8 then, which we're about to move on to, just zooms in on how the G, the tau G, and the epsilon, as well as uncertainty, makes this measurable. This is the measurement layer, how you make the audit concrete. First, you define the intersections set G based on the axis you choose for the deployment. Second, set minimum targets tau G per cell, especially for high impact or historically underdeveloped
Excuse me.
represented
Sorry
cells.
to interrupt, Connor.
Yeah.
Can you please speed it up a little bit?
Yeah, apologies.
Sure.
And then third, we declare epsilon, the maximum disparity you'll tolerate for metrics that matter. For example, false alert rate in triage or missed help prompts in tutoring. Fourth, we report uncertainty per cell, typically stratified confidence intervals, and be explicitly about low-end cells. Finally, we treat it as a living process. We re-audit dataset versions if a cell drops below the tau G or if the gap exceeds the remediate and record it in the changelog. The goal is to make governance concrete but lightweight. We provide 2 copy and paste artifacts here, and these are our toy artifacts then. First, the first artifact there is a coverage table listing each cell intersection and the target tau G and the observation count, which is the NG there, and any shortfall. Second, a peer group metrics table reporting error rates with 95% confidence intervals, plus gaps against the declared reference group. Those 2 tables are the core of transparency. You can't hide thin coverage or subgroup error in a single global number. And you then ship the minimum bundle alongside the dataset wheel and risk register, which I mentioned before. Now a small walkthrough, so this feels concrete. In the toy audit, we define 12 intersection cells from the age band, language variety, and an opt-in self-reported neurodiversity field. We set pragmatic convergent targets, higher where prevalence is higher, and explicit minimum numbers for rarer intersections, so they don't get silently erased. Then we run the coverage table, and it immediately shows which cells are thin. The policy is simple. If a critical cell is below the target, you hold release or clearly label limitations, and you do targeted consent-based recruitment. That's the advantage. Instead of discovering a blind spot after deployment, you catch it during the dataset, build and fix it transparently. Now, once you find the gaps, the question is whether you need a more complex model to fix them. This slide answers that question. Do we need that fancier model? In the toy example, we set epsilon as 3, percentage point cap, and on a false positive rate gaps, because false alerts drive real interventions in triage settings. Before remediation, 2 cells exceed that threshold. We then use deliberate lightweight remediation, targeted data collection for thin cells, and mild reweighting where class imbalance is driving errors and collaboration thresholds. After remediation, the FPR gaps falls within the epsilon rate, and we're explicit about what remains low N. Uncertainty is documenting the dataset, and the risk register stays open so that drift can be monitored over time. And just to be clear, epsilon is deployment specific. You justify it based on harm costs in the use case itself. Moving on. If someone asks, how do you make this reviewable? This here would be your answer. We specify a concrete release bundle, dataset governance model, and a wheel coverage report per cell. That gives you privacy by design in practice, purpose limitation, data minimizations, and opt-out erasures where applicable. It gives you accountability, a clear contact channel, or a record of what is changed and what is known by limitation. The point isn't bureaucracy, it's making trade-offs explicit and checking it audible. So finally, a quick safe training are the limitations. So the quick safe framing is the wheel is not claiming you must capture every attribute. It's a risk and feasibility driven scaffold for choosing what matters based on impact, plausibility, and feasibility. Neurodiversity is opt-in in our framing. We discourage inference and we document missingness and uncertainty explicitly. Intersections can create sparse cells. That's not a bug, it's reality of coverage. So we report low-end confidence intervals so we don't overclaim what evidence is weak. An important Importantly, the wheel doesn't solve bias. It makes gaps measurable, forces explicit targets and thresholds, and supports targeted remediation and transparent documentation. Minimum reporting is intended, use/non-use per cell, coverage targets, decision thresholds, and precision metrics with uncertainty. So finally, and apologies for the long talk, but to wrap up, emotional AI datasets are high risk for bias because effect is culturally and contextually encoded. So we need audits that go beyond demographic and explicitly include cultural expression. And where people choose to disclose opt-in neurodiversity, the data wheel makes this operational. Intersectional coverage targets peer group reporting with uncertainty, and a lightweight release bundle teams can actually ship. Thanks for listening. Happy to take any questions.
Connor, how do you think LLMs can impact the kind of work you're doing?
So specifically towards my PhD or this model here, apologies.
This model.
I think in effect it can be the opposite, as in this model should be what we're looking to affect the LLMs. I'm sure we've all used an LLM at this stage, be it ChatGPT or any of the other ones out there, even Google's one or Copilot. And as you can tell, different people can get different reactions asking the same question, because culturally some things can be acceptable for some, for not the other. And this is what we're trying to target. Sometimes these LLMs seem to avoid the gap, which can be directness, sarcasm, or even just jokingly comments, as it takes most things at face value. Of course, it's improving, but we found that there's still a huge gap in this area.
Can you brief us about the data set that you've taken?
Yes, as in, so the one used in here, this here, then it's just a toy artifact. So what we did here is we broke it down into three groups, our three age groups, which you see 18 to 24, 25 to 64, and 65 plus.
So was it
We
only
then,
the text data or you've taken some pictures or maybe some videos for the consideration?
this was specifically text, so it was a conversational based artifact that went on over a few days for each user. So I think it went on for 7 days in total, and it was purely just text. However, there is room for us to grow into actual reactions, facial expressions, and things like that, in which we plan to do.
Yes, that's why I asked the question. So, like, I don't know about other languages, but as far as English is considered, there are certain words which we usually, I would say, take as a slang, or we say it
Yeah,
indirectly. It's not very direct, and the sarcasm is not, easily understandable in a few
yeah.
cases. So, like, how is it exactly handled with your model, and what is the accuracy of the same?
Yeah, so for these cases, it would come back to here, and it's why we use this cultural wheel where we have this kind of three-step. In my instance, we use the age plus the language variety plus the neurodivergent, but you could use aspects like you said there, where words like slang would kind of be different for different age groups. The younger generation would have a different vocabulary than in the same country with the
But we
same
have
people.
to give that support to the database, isn't it? We have to make it very, very, I would say the database should be very enriched, or, full of latest words, or, I mean, what should I say? The thesaurus has to be very, very, strong and rich in that sense.
Yeah, it would need to be probably a self-learning model to that degree, as in it'd be constantly adapting and evolving as times goes on.
All right. Good luck to you. It's a nice work.
Thank you.
All the best. Thank you.
We will now move to the next presentation.
Is it the last one or the second last, Vidhi?
It is the second last one, ma'am.
Okay, go on.
I now invite Ana Carolina Ferrara Rosa to present a paper on decentralized HAOS, a distributed control model for multiple Home Assistant OS instances.
Okay, can you hear me? Hello?
You can present your screen now.
Are you hear me?
You're audible.
Yes, we can hear you.
Okay. I will present my screen. Okay. Hello everyone, my name is Ana, and today I will present our paper titled Decentralized Rails, a distributed control model for multiple Home Assistant OS instances developed at the University of Brasilia here in Brazil. So, the Internet of Things is a growing field that enables communication between smart devices. Many companies, such as Amazon and Google, are creating their own smart home ecosystems, which is great. But these platforms usually provide limited support for devices from other brands, which makes integration a little difficult. For example, if I have a smart bulb from one brand, it may not work well with a hub from another brand. Right now, we have some good options to this problem, and Home Assistant is one of them because it addresses this problem by offering an open source platform that unifies devices from different vendors in a single environment. Home Assistant has a great dashboard and supports many devices, but it follows a centralized model where each instance controls only one environment. So if you have multiple instances, there is no simple native way to coordinate them. This becomes a limitation in distributed scenarios such as multi-property management, hospitality chains, and smart residential complexes. For example, an Airbnb host who manages several apartments in different locations would need to access each Home Assistant instance one by one to monitor sensors or control devices. So we saw an opportunity to contribute to the Home Assistant community by creating a solution for environments with multiple Home Assistant instances. With a controller, we can coordinate this instance, improving scalability, while still using Home Assistant's dashboard to centralize all the information. We know the Home Assistant offers cloud solution, but we wanted an approach that does not depend on the cloud, preserving privacy, independence, and for us, most important, keeping the system completely free. In our work, we are proposing a decentralized Rails architecture using a controller worker model because this approach enables coordination between multiple instances while preserving local control. Talking about methodology, we used a four-phase methodology. First, we needed to select a base platform for our distributed IoT project. And we selected Home Assistant because it's simple to install and has a good support in community. Then we discovered that Home Assistant doesn't have a native solution for distributed instances for free, and we decided to develop our own solution. In Home Assistant, extensions can be implemented using integrations or add-ons. Our approach is based on add-ons because we wanted a clear separation between the core Home Assistant functions and our solution. And add-ons runs as an independent services and has an independent container. So we developed two add-ons, one for the controller and another for the workers. In our proposed architecture, a single controller manages multiple worker instances. The controller responsibilities are receive sensor data from all workers, distribute rules and automation, and coordinates the entire system. On the other hand, the workers are passive nodes because they do not communicate with each other. They only communicate with the controller. So we have a hierarchy. It's important to note that each worker and controller keep local control of its devices. So we are an extension of Home Assistant, but the solution doesn't interfere with the native Home Assistant functions. All add-ons were implemented as API using Fast API, and we used HTTP for the main communication between the controller and the worker, and MQTT to receive and store data in the controller. We used MQTT on the controller side because we needed a reliable way to collect and store data from all workers. Home Assistant has an API to send and get data, but data sent through this API is not persistent. So if the instance shuts down, you would lost a lot of data. So we needed an additional solution to guarantee data persistent, and MQTT was the best option for that. We tested the system using two Home Assistant instances in different locations. We connected them through a VPN, so they had a directly communication. One instance was the controller, and the other was the worker. So we installed the respective add-ons in those instances. This image shows an example of a worker registered in the controller using the distributed architecture. At this point, the controller already has all the relevant information about the worker, such as its ID, name, location, and utility system. If you are familiar with the Home Assistant dashboard, will you notice that we use the standard Home Assistant interface. We choose it because it's simple, widely adopted, and makes system administration more intuitive and easier to manage. Talking about the distributed process, the registration step is simple, but it needs to be started by the administrator because some initial settings cannot be obtained automatically. The most important configuration is set the controller's IP address or URL in worker add-on because this information indicates where the controller add-on is running, allowing HTTP communication to be established between them. The controller add-on must be configured in one instance and the worker add-on in another. So we need two instances to start the distributed process. After the initial configuration, the worker add-on sends a registration request to the controller add-on, and the controller validates and stores the worker's information and integrates it into the system using MQTT. The worker sensors can be registered at this moment or later during the synchronization step. After registration, the synchronization step starts, and the worker starts sending its sensor values to the controller at a defined interval. In our experiment, this interval was 10 seconds, but it can be changed. We used the official Home Assistant API to retrieve data because it works very well. However, it does not provide persistent storage, as I said. So we use an external MQTT add-on in the controller side. So the entire communication is the worker collects the data from the official Home Assistant API, sends it to the controller, and the controller publishes it to MQTT. When the administrator wants to check the status of the worker sensors, there is no need to access each individual instance. The administrator only needs to look at the controller dashboard because it maintains an updated copy of all sensors data from the workers. Send automation is an optional step, sorry. If the administrator wants to create an automation in any work instance, it can be done in the controller add-on. The automation can be sent to all workers, a group of workers, or a specific one. When the controllers receive an automation, it sends to request to the selected workers with the desired automation, and the workers are responsible for implement the automation. And the workers does it using the official Home Assistant API. Since Home Assistant already validates the automation rules and structure, the add-ons don't need to perform this validation. And here we have a few examples of this entire process. The first image shows sensors from a specific worker in the controller dashboard, so the administrator can monitor everything from one place. And the second image shows an MQTT message that notifies the controller when the light status changes in a worker, allowing the controller to update the value. And the initial results were successful, and we were able to extend information between the two Home Assistant instances using add-ons. We tested data transmission, retrieval, and automation. The prototype worked successfully, showing that add-ons can enable distributed communication between multiple Home Assistant instances, and we hope that this will help multi-instance management without cloud dependence. And for future work, we are planning to test the system with more devices and protocols. And for us, most important, multiple workers, because in our initial test, we just used one worker. We also want to implement bidirectional synchronization because now we have an hierarchy. We want to improve the configuration and credential management. Maybe stop using the official Home Assistant API and external MQTT add-on to have our independent solution. Because right now our add-ons just work with two external solutions, and we want to optimize it and add intelligent automation and mainly in the registration step and anomaly detection. And this is it. Thank you for the opportunity and for your attention. I'll be happy to answer any question. And you can also reach me by email.
Anna, how will you handle the costing part if you, in case, implement someday the work?
Um, Home Assistant can be installed in a ESP32 or Arduino, so it's very cheap. And for us, the most problem is the latency part because if you have a lot of workers send data to an API, it can be very challenging. So our next step is simulate multiple workers send data like 10 seconds to the controller and see if with a ESP32 or a Arduino we can receive this data with low latency.
Absolutely. You pointed out the very appropriate thing here. And secondly, it will increase the complexity at the edges as well.
Yeah, thank
Like
you.
most of the work which we are aiming towards is not to overload the edges, instead, shift the processing work as much as possible to some decentralized nearest node or a particular section for that. But in your case, I think it's going to be more complex at the edges,
Yeah.
which is quite a
uh
contradiction to the technological implementation which we are having these days, in recent
yeah.
times, rather.
Yeah, we choose it because we were thinking about the administrator. So we needed to centralize everything in one place. So it was the best approach for us right now. But we know that the 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 workers as passive nodes are not ideal, and we need to update it. But it's something that we will need to do in the future.
I can see six people in this research work. I rather the paper, research paper. There are six authors, right, in total.
Yeah.
So, do you have your role delegation, um, your role distribution? I would say for this particular work, is it a part of a project or a research?
Yeah, we are a laboratory here in Universidade de Brasília, in Brazil. We work mainly with IoT, so we are researchers, and mainly students for university. So I was a master student, but I finished it, and the others were is or teachers, professors, or degree students.
Okay, good job, Anna.
Thank you.
Yeah.
I now invite Mohammad Azir Terab to present his presentation on investigation of GFDM for wireless communication systems.
Good evening, sir. Good evening, all participants. Can you hear me, please?
We can hear you.
Thank you very much. Uh, Today, I am Muhammad Azhar Darib, PhD candidate in University of Babylon from Iraq. And this work is part of PhD work. Outlines of our work, introduction and aim of the work, contributions and objectives, GFDM. Pulse shaping, filter, channel coding, channel estimation, and simulation results conclusions. 6G wireless communications, we expected that data rates could reach 1 terabytes per second with low latencies not exceeding 0.1 millisecond. These requirements is the GFDM system, generalized frequency division multiplexing system, is considered a good choice for use in this communication systems due to its flexibility, high connectivity, throughput, in addition to high energy efficiency and low out-of-band emission and reduced peak to average power ratio. On the other hand, the limitations and the issue of the GFDM is the control of intersymbol interference, which was issue and difficult and complex implementation. This is applications of 6G and data rates and reliability and capacity and latency, which we uh, try to treat in GFDM system. Objectives of this work: study the different channel coding, estimation, and equalization techniques. Study the effect of CAM order on the bit error rate performance. Study channel coding, different channel coding like convolutional count and low density parity check. GFDM were tested over additive white Gaussian noise channel and Rayleigh fading. And finally, for channel estimation, we use zero forcing and MMSC channel estimation techniques to choose the best performance in all these requirements with GFDM. GFDM the steps of GFDM is the data will distributed over subcarriers and subsamples and transmitted as assets of subcarriers to IFFT to upsampling and filtering and then transmitted sequence. The GFDM is divided into K subcarriers and M subsymbols. This is a GFDM block dataset, M from subsymbols and K of subcarriers. Then there is a matrix of the data and in the beginning of each subcarrier there is a cyclic prefix. Cyclic prefix here different from OFDM is that it begin each subcarrier is begin with cyclic prefix. Each subcarrier beginning with subcarrier with cyclic prefix, and this is will makes the latency as low as possible, and this is very important in requirements of 6G wireless communications. Pulse shaping filter. Here we will suffer from intersimple interference due to non-orthogonality between adjacent frequencies, and this is different from OFDM, which is orthogonal. To treat this problem, we use the rest cosine filter as a pulse shaping filter to eliminate this interference. This is the effect of different roll-off factor of rest cosine filter on the performance. As a mathematical model of GFDM, we put some equations to use equations in our system. We used also channel coding. There are different advanced channel coding. We tried to use different codes and choose the best one. We use convolutional code and low density parity check code. And we can see in results the effect of each of them. Low density parity check code, iterative codes, first introduced in 1962. Low complexity and high flexibility and throughput. This crucial factor in 6G. And this is a block of how it works. For channel estimation, we use two techniques. Zero forcing, which it ignores noise as low as possible, and minimum mean square error, MMSE, which is consider noise and compare between each performance on GFDM. As a simulation results, we try to study identified Gaussian noise and Rayleigh fading channel. We use three different CAM order, 16 CAM, 32 CAM, and 256 CAM, and use three roll-off factors, 0.5, 0.3, and 0.1, two channel coding, LDPC and convolutional code CC, two channel estimation MMSC, and zero forcing. We can see from this plot, from this figure, the effect of roll-off factor on the performance. When the roll-off factor 0.1 give me the blue curve, which is the best bit error rate performance from 0.3 and 0.5 roll-off factor. This figure study the effect of CAM order. It is for 4 CAM order, the black curve, and for red curve for 16 CAM order, and blue curve for 64 CAM order. Here we study the effect of low density variety check and convolutional code and zero forcing and MMSE. It is clear from the black figure, the black curve. It is the best figure. It is the best curve, which is using low density parity check and MMSC with Rayleigh fading channel. And this performance is near the performance of GFDM identified Gaussian noise. Identified Gaussian noise channel, which is mean the best channel and ideal channel. Here we use Rayleigh fading channel in addition to additive Gaussian noise and with low density parity check and MMSC and give the near performance into curves. This is for 16 CAM order and for 32 CAM order, also the same simulations. But here we can see that the blue curve, which is using convolutional code, after about 34 signal to noise ratio, the convolutional code will become most enhanced curve over low density parity check. But before 34, there's an improvement in low density parity check with MMSE. This curves also for 256 CAM order and give the near simulation results. Conclusions of this work. In this work, different simulations were done on this system to choose the best performance for the future studies to deal with it. Actually, we has we have additional works in PhD depending on the results of this work on this paper. The best better performance were achieved when using a best pulse shaping filter of a type raised cosine filter with roll-off factor 0.1 and low density parity check as kind iterative algorithm gives the best performance. Due to high connectivity, higher order CAM was needed, but that will give degradation in the bit error rate performance with the GFDM system. Higher order CAM means degradation in the bit error rate performance with GFDM system. And thank you for your attention, and I ready for any question.
Yeah, how long has it been for you to get enrolled in PhD?
Excuse me?
Are you a research scholar, right? This is your research work.
Yes, yes.
Yeah. So how long has it been?
How long? About 3 months till now.
About three. Okay. So this is very, very initial phase, right?
Yes.
Yeah. So what is the entire idea which you're going to uh, address in your work, if I can
I
ask that?
will, yes, I will integrate the GFDM with additional techniques to give the best requirements for 6G,
Mm-hmm.
like NOMA and non-orthogonal multiple access and cognitive radio. And actually, I integrate these three techniques, GFDM with NOMA and cognitive rates and cognitive radio, and give very good results till now.
All right. So I'll just give you a suggestion that would probably be help you in this journey of your research work.
Yes.
That whatever algorithm, whatever parameters we converge on, we need to have a strong base behind that, right? We must have proper logic of selecting the kind of algorithms we are comparing or the kind of parameters we have chosen. So we must have proper logic behind that. So just try to focus on those things that
Yeah.
if we are taking up, let's say, 3 out of 10 parameters, why they are very important and what made us take them. And same goes for the algorithm as well. The techniques,
Yeah.
basically. Yeah.
Thank you
Thank
for
you.
this suggestion, but I'm in the beginning of the study and I will try to choose different values and compare between them.
Yeah,
Thank you very
and
much.
in order to have a strong base behind that, you must implement that. You must have your own results, so that it can give a good backing to your work, to the
Yes,
validation. Yeah. Thank you.
yes, I understand. Thank you very much.
I sincerely thank our authors. Yes. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 11th version and all the previous 10 versions of the conference. We will be happy to have you in the 12th version in 2027. All the presenters would be getting their digital certificates within 2 working days via email. The publication will be live within 7 to 8 months. Kindly cooperated with the team of ICICT 2026. I also thank our session chair for chairing this session. A token of appreciation has been prepared for her. A token of appreciation to the chair on behalf of Team ICICT 2026 and Global Knowledge Resource Foundation and partners. Thank you for your valuable presence. I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. Thank you for your valuable time. I hope you have a great day ahead and take care. Thank you. Thank you,
Thank you,
everyone.
everyone, and wish you all
Thank you very
luck
much.
for your future work. Thanks again.
Thank you.
You.